All right, you guys, so let's get started. Inverse function, but let's not forget the domain of f of x. The denominator cannot be 0. So this is a function that only exists for x does not equal -2, right? Let's keep going. We switch the x and the y, so remember f of x is really y. We make that x is equal to 3y over y plus 2. I'm going to multiply both sides by the denominator, or you can think of it, if I put a 1 under here, as cross multiplication. And that's x times y plus 2 over 1. I guess it doesn't really need to be over 1. Is equal to, and then 1 times 3y, which is just 3y. I'm going to distribute my x, y, and I'm solving for y. I need to get y by itself, plus 2x is equal to 3y. I haven't done anything to this side because it was just distribution on the other side. If I am solving for y, I would like to have all my y's on the same side. So why don't I subtract xy from both sides? And I'm going to get 2x is equal to 3y minus xy. And here I can factor out that y, and I can tear apart kind of those terms so that I can get y by itself. So I'm going to keep 2x over here, but I'm going to factor out that y, so then I just have 3 minus x, and then divide both sides by 3 minus x. Okay? So that would be my inverse function, but this inverse function does not work where x is 3. Okay? For x not equal to 3. And the way you want to write that is, if we want to make it g of x, the inverse of f of x, or we just write it like this, f of x -1, there, that's inverse, is equal to 2x over 3 minus x. Okay, and not only for x is not equal 3, but x does not equal 2, even though it hasn't changed here, it's still part of that original function, so we've got to have it here. And x not equal to 3. And the original function and inverse are functions of each other. Okay, so this one, where is this going to exist? Remember, under the radical, it cannot be a negative number. So if I enter in 4, for x, that's going to give me the square root of 0. If I enter anything smaller than 4, okay, 3 times 4 is 12, and I know 12 minus 12 is 0, and that works. But that means that anything smaller than 4, like what about 3 times 3? That's going to be 9 times 12, and that's going to give me a -3, okay? So if 4 is what gives me my 0, I know that x cannot be less than 4, right? So x cannot be less than, that's not maybe the best way to write it. Let's write it as for x is greater or equal to 4. Let's write it like that. That would be the domain in our original function. And so let's go ahead through. We're going to change this to x equals the square root of 3 times y minus 12. So I'm going to square both sides. Equals 3y minus 12. Add 12 to both sides. And divide both sides by 3. So we get y equals x squared plus 12 all over 3. So this is where you guys, I'll show you on Desmos in just a second. This is where you really have to have those domains defined for them to be inverse functions. So let's go over to Desmos where I've graphed these now. So our original function is this blue line right here, okay, the square root, and you can see our domain is that It does not exist lower than 4. There's a point at 4, 0, and anything less than that on the x-axis, it does not exist. It only exists from here, there. Okay, and then this purple line, this line is the y equals x line. So if you can remember, what that means is that, let's see, I think I can write on here. Yeah, oops, that's funny. Can I clear this off? So what that means is, where did that come from? That's funny. What that means is that for every point, for inverse functions, for every x, y, there's going to be a flipped point. The y and the x is going to flip. So if this is 4, 0, then this is 0, 4 right here. And this is, and if this is, I don't see another exact point, but you get the idea. Every point here is going to be the inverse of a point here. And what happens is those get reflected across that y equals x. This is y, whoops, this is y equals x, which is why when we compose our functions and we get an x out, we have proved that, because we proved it's reflective across this y equals x line. But here's why that original domain is important. This part here of the inverse graph is not actually an inverse of our original function, because our original function domain did not go past here, right? So for that one to be, for this green line to be the actual inverse of the blue line, it's only going to be for x is greater than or equal to 0, right? This whole part where x is negative, right, is not going to be part of that reflection there. Okay. All right, you guys, so I don't want to do all of these. I want to give you guys a chance to practice this, but let's start off with A. That one looks maybe a little more complicated. It's g of x minus 2, which means we take our g of x, whoops, our g of x function, but everywhere we see an x instead, we do x minus 2. So that's going to be the square root of x minus 2 plus 1, or just the square root of x minus 1. Okay. Then let's see, what else would be a good one? What about this one? What about D? F of 1, right? So that means we're going to put 1. Let's find f of 1. Let's find the output for that, and that's going to be the input for the next one. And that's going to be 1 squared plus 2 times 1. So that's just going to be 3. So f of 1 is 3. So that means we take f of 3, and that's going to be 3 squared plus 2 times 3. So our final output here is going to be 9 plus 6, 15. Double check me, I just did that in my head, but our answer for this one should be 15. Whoops. 15. How about E, f of x plus 1? So instead of x and f, everywhere we see an x, we're going to put x plus 1. So x plus 1 squared. Don't forget that's a binomial. You can't just square each term. Plus 2 times x plus 1. And then if it wants us to evaluate it, I'm not sure if that means it wants us to simplify it, but there's no harm in practicing that. So x plus 1 times x plus 1 is the same as x plus 1 squared, right? So x squared, 1 times x is x, 1 times x is 1. So what that is x squared plus 2x plus 1 plus, and then I'm going to distribute this 2x plus 2. So now we just combine our like terms, and I have 1x squared, so that's just going to stay there. But I actually have 4 x values, and then I actually have 3. And actually, I think I can factor this, because if I do two numbers that add up to be positive 4 and multiply together to be positive 3, that ends up being x plus 1 times x plus 3. So that's kind of cool. So we get down here and then we can, factor it again. And then let's go ahead and do f. Let's do g of f of x and see if these two are actually inverses of each other, okay? So, and remember, technically you would have to do it both ways, but it's just asking for g of f of x. So in g of x, right, everywhere I see an x, instead I'm going to put, oh, actually, maybe this is a good way to write it. Instead, I actually have to put x squared plus 2x, right? So we have the square root of x squared plus 2x plus 1. So I'm going to factor that, and I bet I will get something that I can cancel out here. Two numbers, if I factor that trinomial x squared plus 2x plus 1, I'm looking for two numbers that add up to be 2 and multiply together to be 1, and that's going to be 1 and 1. So x squared plus 2x plus 1 is actually x plus 1 times x plus 1, which is x plus 1 squared, right? If I have the square root of two exact same things times each other, that just is x plus 1. Right? Did I miss anything there? I am checking because they do not end up being inverses of each other. So I just wanted to double check there, because I get, when I simplify it, x plus 1. If they were inverses of each other, I would have just gotten x. So not inverses of each other. Double check my work, and then try the other ones on your own. All right, 86, if x over 3 and 5 over 6 is multiplied by 6, the result is 2x plus 5. Is x over 3 plus 5 over 6 equivalent to 2x plus 5? So I looked at the hint for this one because I was trying to figure out how best to explain it to you guys, and the hint was really cool. The hint says, if you read it in the book, if you put in a value, like a number for x in each of these, do you get the same thing back, right? So if I put in 9 for x here, that's 9 over 3, plus 5 over 6, which is, oh, I shouldn't do 9. I was trying to make that easy, but it's not. So I'm going to make this, I'm going to make x 3. If I have 3 over 3 plus 5 over 6, right? 3 over 3 is the same as 6 over 6, because that's just 1. So 6 plus 5 is 11 over 6. So is that the same as 2 times 3 plus 5? And 2 times 3 plus 5 would just be 11, and we have 11 over 6 here. So they are not equivalent to each other. So the reason is, if we had, like, if we wanted to go back, the way I was originally thinking of it is, if we wanted to say they were equivalent, and I said x over 3 plus 5 over 6 was equal to 2x plus 5, right? And this goes back to some of our rules. And we multiply this whole thing by 6. What do I always tell you guys? You have, what you do to one side, you have to do to the other. If that was the case, then I would also have to multiply this side by 6. So we could say that 2x plus 5 is equal to, or x over 3 plus 5 over 6 is equal to the other side times 6, right? But you can't just say that they are equivalent to each other, because you haven't performed the same operation on both sides. I need to plug in really quick, so I'm going to pause.